We've made it to our final review topic of chapter 2, the mole. All right, so if you recall, the mole is looking at the particles in the atomic mass in grams of an element. And so when we look at this, we have our molar mass. Now, when we think about those number of particles, we have the 6.022 times 10 to the 23rd particles. What is that? Anybody remember? N sub A. This is Avogadro's number. Okay, and so this tells us number of particles or entities in a mole. So if I have a mole of hydrogen atoms, I have 6.022 times 10 to the 23rd hydrogen atoms. If I have a mole of students, I have 6.022 times 10 to the 23rd students. All right, so should be familiar. We go over this super detail in the prep classes. Okay. When I look at the mole and atomic mass, all right, when we think about our various different compounds, so if I look at a piece of chalk, 1 mole of chalk is going to be 172.19 grams. And so my molar mass of calcium sulfate dihydrate, which is chalk, is 172.19 grams per every 1 mole, or 172.19 AMU. The numbers get used interchangeably. Okay, oxygen, if I have a mole of oxygen molecules, I have 32 grams of oxygen per every 1 mole. All right, so my question for you is, do you remember how to calculate our atomic or our molar mass? All right, so I'm going to give you 4 different compounds. So sometimes it's called the atomic mass, and that's when we use AMU. Sometimes it's called the molar mass, and that's when we use grams per mole. All right, so here I have 3 compounds for you. Nitric acid, okay, carbon tetrachloride, okay, acetic acid. You could also write that as CH3COOH. All right, and then this other crazy compound here. C6H5CH3. Okay, this one is an aromatic, so it's going to be something that looks kind of like this. Okay, or all right, that's what it would look like. Okay, anyway, so calculate the molar mass. See if you remember how to do this. I'll show you on the nitric acid one. So remember, we're going to take hydrogen, which is 1.008 grams per mole, nitrogen, which is 14.01 grams per mole, and 3 oxygens, each at 16 grams per mole, and we'll get 63.02 grams per mole. Okay, so practice, do the other 3, and then, or pause, do the other 3, and then unpause, and I'll give you the answers. Okay, so you should have gotten 153.8 grams per mole, 60.05 grams per mole, and 92.14 grams per mole. Okay, so essential skill. We did it all the time in our previous class. We're going to do it all the time in this class. And if you go on to continue studying chemistry, or you major in chemistry and become a chemist, you'll still do this all the time. It's very fundamental. We calculate molar masses all the time. Okay. Just to put some things in perspective, you know, when we think about it again, when we look at that Avogadro's number, 1 mole is exactly that 6.022 times 10 to the 23rd entities. So I can be looking at a mole of atoms, a mole of molecules, a mole of formula units, a mole of, like I said, students. I'm not sure I would survive a semester if I had a mole of students, because that would be 6.022 times 10 to the 23rd students. I'm not sure I would get anything graded if I had that many students. All right. As a visual, a tablespoon of water is approximately 1 mole. 22 pennies is approximately 1 mole of copper. Okay. All right. So let's do a couple quick practices. All right, so if I have 1 drop of water, I want to know how many water molecules are in that 1 drop. Here's a couple equivalencies for you. There's approximately 20 drops in every mil. And I say approximately because it really depends on like how much you squeeze and the type of dropper you're using. But the generally accepted value is 20 drops per mil. So we'll use that for this. And then we have a density of water. So see if you can figure out how many water molecules are in this drop. All right, hopefully you've done the math. Oh, I don't have an extra space there. Okay, I'll show you the other one right here, and then underneath it, I'll do this problem. Okay, so problem 1 was 1 drop. Thought I had an extra page in here, but apparently not. 1 mil in every 20 drops. 1 gram for every 1 mil. And 1 mole of water for every 18.016 grams. And so this is our molar mass. And we have 6.022 times 10 to the 23rd molecules in every 1 mole. And so that's going to give us 1.7 times 10 to the 21st molecules of water. Okay? All right. Now, I want to know how many hydrogen atoms are in this 1 drop of water. Okay? Well, I know how many molecules of water I had in that 1 drop. So how do I go from molecules of water to atoms of hydrogen? All right, so we can take our 1.7 times 10 to the 21st molecules. I have 2 atoms of hydrogen in every 1 molecule of water per my formula, H2O. And so I'm going to get 3.4 times 10 to the 21st atoms of hydrogen. Okay, so again, this should all be review. This we did extensively in the prep chem class. So this is a little bit of review here. If you're struggling on this, I urge you to go to your textbook and do the extra practice problems in there. There will be a whole bunch of extra practice problems in the textbook. If you're still struggling, come see me in office hours, and I've got a lot more practice problems that I can give you to review this. Or if you can't come to office hours, but you want a little bit of a review, let me know, and I'll pull the specific videos from either of my prep classes, like Chem 120 or Chem 100. They all teach the same thing, and I can link the direct videos for you, so you don't have to dig through my YouTube channel. I know which chapters and everything's in, so I can pull those easily for you. But definitely reach out. Let me know if you are struggling on any of these, and I can give you some review.